We are going to discuss in this video how to calculate work during volume changes. Now we learned back in Physics 1 that force is equal, or work is equal to force times displacement. But when we talk about gases, we don't want to talk about force, we want to talk about pressure. So we're going to have a container of gas. You can imagine that there is a piston on top that then, as you apply a force over this area, you're applying that force over that area, and it's going to displace the piston down a certain delta D, which is then going to compress the gas or change its pressure. So we're still going to apply a force over distance. We're just going to look at it differently, because instead of looking at moving an object from 0 meters to 2 meters, we're looking at a change in volume, because remember, our container here is three-dimensional. So I'm going to take the idea that pressure is equal to force per area, and that force is equal to pressure times area. And area times the displacement is going to be the change in volume. Now, anytime you have a delta something, you can actually turn it into a D, or a smaller increment. Delta is always the macroscopic increment, and D is always the microscopic increment. So we can also write this as work is equal to the integral from V1 to V2 of pressure dV. And so if the pressure is constant with volume, you get this relationship here. And if the pressure isn't constant with volume, I would have to give you a function of pressure in terms of volume, and then you'd have to integrate in order to get the work done. Another way of doing that then is, if you have a pressure versus volume graph, you can instead find the area underneath the curve. So if we could figure out what this area is, you can establish also what the work done on the gas is. Now, of course, in a problem, I'm not going to give you a strange shape like this if I want you to use a P versus V graph. Instead, I would give you something like a rectangle or a triangle or something where you already know the area formula and can apply it. But remember, it's always the area underneath of the line, not beside, not above, but the area underneath of the curve. And it's the same thing as doing an integral. So work where there is an expansion is going to be positive. And when the work is negative, that means that there has been a compression. So you have to keep track of those sign rules.